About that, we can go ahead and calculate out how much current would be that would take required to power up the coil of our relay. So we figured out about 100 milliamps current or 500 milliwatts. So a lot of times this stuff is in watts. You just have to do your total conversions. So then our next thing is that what we want to do is we want, so that we can wire this thing up, we need to get the actual pinouts for our contacts. So this one comes in two forms, either just one set, it has two sets of just normally open contacts, or what we have is the double pole, double throw with a set of normally closed contacts and a normally open contact. And then our coil to energize our circuit. So let's take a look at just our contacts since we already have this on. So here's our, so what we're going to do is, then what you're going to do is the next thing you're going to do, so that when you're wiring it up, you know what the wires pin up with. So I'm going to get rid of the ones that we used that were out of the textbook. So we know that we have our common, and that's what's common to both the normally closed and the normally open contacts. So let's put this back. So we were saying that our coil is de-energized, and our contacts back are this way, so I've got our normally closed. So on my common, what would be my pin number for my common there then?
11.
So on this one here it would be 11. So we can use this set of contacts first. So that's our common that's both. So then what you're going to do is you're just going to put on there, whether if you're doing schematics or whatever you're doing, you just put in there with a couple of small numbers and people know what you're talking about. That's our pin number for that one. So this one's 11, and what's going to be the number for this one then?
21.
21. And then for our normally closed contact, it's going to be what number?
A1. 12.
12. Yep, you got to make sure that you don't cross change, either don't go 11 to 22. Make sure you stay in with one set of contacts. Keep your numbers the same there, your group of numbers. Okay, so this is going to be 12, then our normally open for this one is going to be what number?
14.
14. And this one here for our normally closed is going to be what?
22.
22. And then this one's going to be 24. Okay, so then when you're wiring it up then what you're going to do is you're going to just take your plus 5 volts from your MyDAC, or well, I don't think, the MyDAC won't be able to, what is the, Dave, did you try with the MyDAC and fire it up? Did you, Bob, or somebody tried it?
I think we use the 5 volts for the MyDAC, but then we get the power supply to activate the relay.
Yeah, I don't think the 5 volts had enough. I don't think the MyDAC had enough current, did it? But it might if you use the plus 5 volts source, but it won't power up the LEDs. It'll probably energize the coil, but it won't power up the LEDs because by the time you add in, because what it's going to do is it's going to take 100 milliamps just to energize the coil, and then it's going to take another approximately another 9 milliamps. So you're at, so to energize up both the coil and one LED is take about 110 milliamps.
And I think we use 2 separate power supplies.
Yeah, and you should, yeah. Then you can do that, or you can use one power supply. But if you use 2 separate power supplies, then you can kind of see how that would work. Yep. So 2 power supplies is a good way of doing this. That's how I do it, even though they're both 5 volts. That's a good way of doing it.
Well, it takes about 6 volts for the coil to really activate.
That relay is actually 12 volt.
It is a 12 volt relay. That's what I think. That's what I thought. I thought it was a 12 volt relay.
It's 12 volt relay, but we're using 5 volts.
Yeah, you need 5 on one and then
Yeah. So what you're going to do is you're going to do 5 volts. So what you're going to do is 5 volts on your for your LEDs, and then the coil voltage is actually 12 volts DC. So you are going to have to use 2 power supplies.
Yeah, it'll kick on about 6.
Yeah. So if you're trying to use a MyDAC or something, you might be able to get by. But yeah, just use 2 power supplies. One that's set at 5 volts and then one at 12 volts DC. All right. So this takes care of our contacts. That's what you're gonna. That's what you're gonna drop in your in that little box there. You have to redraw that up and put your pin numbers for your relay contacts in there. Put your source voltages so that somebody can actually interpret what you got going on there. All right, so then pins A1 and A2 are going to be that's going to be for your coil. So that's what that's representing. A1 and A2 is your coil. So I'm going to go back to the So either on this one here, what you want to do then, our coil, so that you know exactly where to wire everything up, is that your coil then is going to be A1, A2, and then put some labels on there. So then you know that you're going to come off your negative side of your 12 volts. So this one's going to be your 12 volts DC. It's going to come around. Here's our negative side and our positive side. Our current's going to come through our coil and then through our switch. And you can just use either a piece of wire, or you do have some switches that are in your kit that you can use for switches. And then back to our source. So we're going to power up our relay with 12 volts source. So you can hook up your negative side of one side of the coil to A2, your switch to A1, and then the other side of your switch to our 12 volts. When I close that switch, I connect the pad, I energize the coil, these two contacts are going to move down, and I'm going to turn on my green LED. I de-energize, I open up the switch, it unenergizes the coil, my contacts go back up, go back to their normally closed positions, and then my red LED turns on. Alright, pretty straightforward then?
Oh, absolutely.
Alright, good.
Glad you're on top of it.
Alright, yeah. So if you need any help,
We're coming to you then.
If you
Need any help, ask
you got it
Bob.
figured out, yeah?
I'm looking here.
Alright.
Listen, Vincent McCollum.
Alright, if you haven't grabbed your final AC notes, I'll just pass them around. Grab them. If you haven't grabbed one, just grab one. If you already grabbed one, don't grab another one, because I won't have enough for everyone. So, but pass them around grab one if you haven't taken one. Oh yeah, it does. That's what I say, you gotta try everything out.
We got one?
I don't know why.
Okay.
Yeah.
Sure.
Alright, so is there anything else in chapter 11 that you want to go over? Or not 11, 7. Otherwise, those are the big two main things. The solenoid and the relay. Otherwise, everything else is just good to know. Alright. Alright, so let's go over what's going to be on the
What about chapter 14?
going to be on the final here. Alright, so some of the things that you should know about, some of the ones that people forget are about the power factor. You kind of understand, what the power factor is. If I have a power factor of 1, what am I? Purely resistive or purely resistive. If I have a power factor of 0, I'm either more inductive or more capacitive. Know all your units. We have that again. Some of the ones that we don't use, but we should know. Some of them get repeated again. What's the amount of energy, electrical energy stored in an electrostatic field? What component is an electrostatic field? What type of component? Capacitor. And then an inductor is kind of more of an electromechanical or electromagnetic field.
Capacitor is electromagnetic field, you said?
No. Capacitor is electrostatic.
Oh,
Yeah. And then the amount of energy that's stored in it is the joules.
Yeah, we'll remember that.
Yeah, don't forget that. Make sure you know your formulas. Let's see here.
Why don't you just pass that over?
Some of your conversions. Make sure you know how to do your conversions. Make sure you know how to read an oscilloscope, because I bet you old chapter 8's going to come back and haunt you. All right, I've only been hitting that about the last 8 weeks here.
Are we allowed to use our midterm notes?
And you can use your midterm notes along with your new ones. And then you can also be able to use your equation sheet. So you can have 3 sheets out. Your equation sheet that I handed out to you, or any other approved equation sheets. If you guys made one up here on your own, you can use that one. Pre-approved. And then your midterm notes. A lot of it will be majority of it will be multiple choice.
Yeah, I think I'll let you.
And then what I'll do is I'll probably have you do it on the Scantron so that if you guys want to find out your grade before you leave for you can stick around and I'll quick run through the Scantron and I'll give you tell you how you did. Huh?
Kurt.
Yeah, I used them not your class because you had such a small class.
Can I use my folder, the rectangular?
Yes, yep, any pre-approved worksheets that you built up here on your own and stuff is fine. Yep, for anything with the equations and stuff, yep.
So if you prove it, Bob, it's fine then. So,
You can try that.
that doesn't sound too complicated.
You know, you should know about, the difference between a high pass and a low pass filters, know what frequency cutoff is. What are some of those numbers that we use? 70.7% comes in a lot. When we're calculating on RMS values, we use that 0.707 or 70.7% of our voltage source, to calculate our voltage peak to calculate on. So, at 70.7% comes in handy. No chapter 7s, but it will be through 8 through 14. And we're going to go over 14 tomorrow. Make sure you bring your, I'm going to try going home tonight. I'm going to try doing that lab at home using the MyDAC. So make sure you bring your MyDAC and your transformer tomorrow. And we'll probably meet in that computer room if it's available. And we'll just do that lab together in the room. So we'll see how that goes. There will be some troubleshooting. What would you measure for voltage across the, capacitor, inductors, and stuff like that.
Somewhere in there.
And then, let's see here. Yeah, and you should understand, understand your vectors, frequency cutoffs, resonating frequency, and then there will be an RCL circuit that you have to do. Okay, just like we do on our series, there'll be a series RCL circuit, just like we did on the beginning of chapter 13, those worksheets that we handed out. It'll look just like that, except I might have I might throw you in for a loop and might throw you in, that I might just give you I might give you X of L, but not give you X of C. But if you know X of L at a resonating frequency, what's X of C going to be?
Equal.
Same as X of L. So it just might throw a little bit of that loop in there for you. But it'll be calculated based off of the resonating frequency. Depends on how big of a pain in the butt you are. It might be 75 or 100. Some people might be only 5 or 10. Really? Yeah. Really? All this really depends. Yeah. I don't know. No, it's typically more the circuit that's for the people that kind of separate the A's and the B's. Yeah.
So can we do that?
It doesn't really affect your grade that much. If you know it, then you know that you're probably an A student.
Can we draw like a Christmas?
As long as you do good on the multiple choice. Yeah. What's that?
Can we draw a Christmas tree instead of a box furnace?
All right. Let's see here. All right. So we'll call it an early day. We're just starting chapter 14. So. Wow. All right.
You're on point.
All right.